Hello friends, I welcome you all to Crack Easy. In this video, we will continue the first part of Rootlocus. This will be a video full of tricks which will be very important to you while solving the numericals on Rootlocus, and truly enjoy the video and watch till the last. So, like in the previous video, we have learned about the basic tricks we should know in Rootlocus. In this video we will going to learn about the procedure, conventional method which should one follow while solving the problems. So let's start. First step in the Rootlocus will be to find number of poles, number of zeros. So first we will need a transfer function which will be given, which will be negative feedback transfer function or positive feedback transfer function. So let's suppose the transfer function is negative feedback transfer function. So number of poles, how to calculate number of poles? The number of poles will be there in the denominator of the transfer function. So if the given transfer function is g of s into h of s equals to s plus 2 s plus 1 s plus 3. So suppose this is the given transfer function. So number of poles will be 2, minus 1 and 3. S plus 1 equals to 0, equated to 0, then the poles will be 2 and minus 1 and minus 3, and number of zeros will be only 1, that is in the numerator. So therefore the number of zeros will be 1 and and 0 will be s equals to minus 2. Okay, so number of poles will be s equals to minus 1, s equals to minus 3, and number of zeros s equals to minus 2. And what about number of branches? So number of branches we will calculate if number of poles are greater, then the number of branches equals to p, and if number of zeros are greater, which is not possible, but still if number of zeros are greater, then the number of branches are 0. Or so in this question number of poles are 2 and zeros are 1, therefore poles are greater, so therefore number of branches equals to 2, therefore there are 2 Rootlocus branches here. Now second step is to draw a pole zero plot. So let's draw a pole zero plot. So this is our pole zero plot. Okay, this is real of s and this is imaginary of s. Okay, so first two poles are there. At minus 1 one pole, at minus 3 another pole, and at minus 2 there is one 0. So 0 always draw 0 by a sign that is circle, and poles by a sign that is cross sign. Okay, so this is our poles and this is our zeros. Therefore what we see that there are 2 poles and 1 0 in this graph, pole zero plot, and we have drawn it. Okay, now next thing which next step will be, third step will be from where to start and at what point we should end. In the previous video I told you about the starting point and the ending point of the Rootlocus. So Rootlocus starts at poles and ends at zeros, and if zeros are not present, then if there are no zeros, then ends at infinity. So how many zeros are there in this transfer function? There are only one zero, and there are 2 poles. So for 2 poles, for Rootlocus we need 2 zeros for 2 poles, but there is only 1 0. Then therefore one pole will be one pole Rootlocus will be ending at infinity, and one pole Rootlocus will be ending at 0. Therefore for this, let's say for this root locus is ending at 0. Therefore at 0 as in previous video we have learned, at 0 k is equals to infinity, and at pole k is equals to 0, because from pole root locus starts. Therefore arrow will be from pole to 0. In this case there is no such 0 for this pole, therefore it will end at infinity. Now let's check where at what region of x-axis the root locus lies. Therefore in this the root locus will be checked by for this let's suppose for this pole, is there any pole or 0? No. In the right side, no. Therefore 0 poles and 0, therefore 0 is even number, and hence there will be no such root locus on the right side of this pole. Okay, for checking root locus, what we have to check? Number of poles, zeros on right hand side. If even, no root locus. If odd, root locus present. Okay, so here in at pole equals to -1, in the right hand side there is no poles, and pole p plus z, poles plus 0, therefore an even number is there, therefore no root locus. In between this pole and 0, on the right hand side of this 0, how many pole plus 0 is present? There is only one pole present, therefore the number is odd, and hence root locus is present. Here. Now let's move on to pole -3 pole. So in this pole, in the right hand side of this pole there are two poles plus 0 equals to 2 value is present, and which is even, and hence there will be no such root locus present. Now for this segment, the poles and zeros sum present on right hand side is 1, 2, 3, therefore the number is odd, and hence root locus is present here. Okay, therefore root locus is present in these two branches, and hence the root locus for this pole will be ending at infinity. Okay, so we have two segments of root locus. Okay, therefore the number of branches are also 2. Okay, therefore we have got 2 branches. Okay, so root locus starts at k equals to 0 and ends on k equals to infinity. Okay, now next step will be to find the asymptote. Number of asymptotes formula will be p minus z. P is poles, z is zeros. So in this problem, how many poles are there? There are 2 poles. And how many zeros are there? There is only 1 zero. Therefore number of asymptotes will be equal to 1. And asymptote, what is asymptote? Asymptote is the line ending at infinity. In the previous video we have seen that the poles which does not get any zero, then the root locus ends at infinity, and hence here the one root locus ends at infinity, that is this root locus is ending at infinity here. Therefore we got one asymptote. Okay, so but what will be the angle of the asymptote? Will it be going like this, or this, or this, or this? In which direction? Therefore we need to calculate the angle, and what is the formula for angle? 2n plus 1 into 180 degree upon p minus z. Okay, so this is the formula for finding out number of angle of asymptotes. Okay, so here n is 0, 1, 2. If we have to find the angle, we have only one asymptote in this problem, therefore we will put n is equals to 0. So phi of 0 is equals to 2 of 0 plus 1 into 180 degree upon p minus z, that is 2 pole and 1 0, therefore 1 is equals to 2 180 degree. Therefore only one asymptote is present and its angle is 180 degree. Therefore our root locus will be going like this straight line. Okay, now centroid. So what is centroid? Centroid is the point at which asymptotes meet. Two asymptotes meet. Therefore, but here is only one asymptote present. Therefore, we don't need to find centroid. But if in case there are two asymptotes present in the solution or in the transfer function, then we need to calculate centroid. Two or more asymptotes are present, but in this question there is no asymptote present. Therefore, centroid will not be there. The basic condition for centroid is that we need two asymptotes here. So what, let's check the formula for this: summation real part of poles minus summation real parts of zeros upon p minus z. If there are complex poles and zeros, then take the real part only of the poles and zeros. This will be the formula. Now let's move on to where the root locus lies on the x-axis. Like this is the differentiation between positive feedback and negative feedback. If the generally if nothing is given, then we have to consider the feedback as negative feedback, and if it's given that it is positive feedback, then we have to take the case for positive feedback. For negative feedback, the basic difference is asymptotic angle. In the asymptotic angle, we have to take here 2n plus 1 into 180 degree, as we have seen, upon p minus z, angle phi of n, where n is equals to 0, 1, 2. Here we have to take phi n equals to 2n into 180 degree upon p minus z. This is the basic difference between the two. Okay, and second difference is, this is first difference, and second difference is the on right hand side, here poles plus zeros are equal to odd, then root locus present. Here on right hand side, if p plus z is equals to even, that is vice versa, then root locus present. Okay, when on right hand side poles plus 0 will be even, then root locus is present in the positive feedback case. And we have seen how to find or how to check the root locus on right hand side, root locus present or not. Okay, so let's move on to our question number 1. This is the basic difference. We should know this, and this is the trick. Okay, this is the trick for finding out, because in many examinations like gate examinations and competitive level examinations, such type of questions are asked where student doesn't know for positive feedback what we have to do, because it is not present, it is not taught by the teachers in the colleges mostly. Therefore they don't know for positive what to take, and they do like negative, and they do the question similar to the negative feedback, and answer becomes wrong. Okay.